done will be high for 2 clock cycles with this code. So that's a bug. Okay, and then this sig out is a variable that I'm using just inside this process. So if I really want that signal to show up on the output, remember there's a signal out for this entire circuit, I need to put that local variable value into my signal out. Okay, take a look at this. This looks a lot like your code from other classes. So this should be actually more friendly than what's coming up down below, which is the doorbell code. Okay, the doorbell code, as we talked about, when the button is pushed, this state machine sends a start signal to the music player. It waits for a done signal to look for another button push. Okay, so this is I can almost get it on one page. Not quite. Okay, so let's see what's going on here. We are using a case statement here. Okay, don't think, let's see, case statement. I didn't put the syntax for a case statement into the slides, but you can always look it up online, or it's not too complicated. Case that's a VHDL reserved word. Case, and then what comes here is your signal. I'm using a signal to hold the state value for the doorbell process. And remember, doorbell state is a signal. Doorbell state is a signal declared at the beginning of the architecture. Doorbell signal, and it's of type state type. So remember, I declared this type, and this type can only have these 4 values. Okay, so doorbell state is a signal of type state type and can only have these 4 values. So let's go back down below. Okay, so case, and then this signal that has one of those values declared in the type that we defined, and is. So case, and then your name, and then is. This is another reserved word, or it's part of the format of the case statement. Then when, and then these are the values that doorbell state can have. These are the values that doorbell state can have. So these are the values that's inside the parentheses when I defined that state type. Okay, when doorbell state equals this, then do this. When doorbell state equals this, then do this. When doorbell state equals this, then do this, and so on. And then if for some reason you have some odd value inside your doorbell signal and none of these match, which won't happen, then there's a when others, and that just catches everything. So let's say you had a couple of states here that did the same thing. You could use when statements here, or you could just use when others. And if these, for example, button and not done and buttoned and done did the same thing, you could just delete them and put their code down here, because the other values of doorbell state have already been described, what their code is. When others is if it's anything other than the things defined in the when statement or shown in the when statement, then do this code. Okay, so let's see what's going on here. Oh my, it's 3 a.m. So let's see. When no button done, that is So here we are. That's this state right here. We have no button, and we've already seen a done signal. So this state right here is what I'm calling no button. So we have no button, but we are done. The music is done. Okay, so let's see what we do in that state. In that state, if the button equals 1, if we are in this state and the button equals 1, then we want to change the state to button and not done with a start signal. Okay, so this state right here is the seen a button push, and we're not done yet, but we have the start signal on. Okay, if button isn't 1, then you just for safety purposes, I had not start. Yeah, start equal to 0. Okay, so this is the value of start right here. Okay, then the next place we go is if we are in this start state. In other words, this is the seen a button but is not done yet and has the start signal high. If we are in this state, we have to leave that state on the next clock tick. We can't have our output, can't have our start signal go high for longer than 1 clock cycle. So we need to leave this state. So whatever comes, whatever happens on the next clock tick, we need to go to the next state, which is the button's been pushed, and it's not, and we haven't got a done signal yet. And we have start equal to 1. Okay, so output equal to 1. From there, we go to the next state. Okay, so this is where we've seen a button push, but we haven't seen a done signal yet. Okay, we make sure that we set start equal to 0 here. Okay, then if we are in this state and we see a done signal, actually there's one more arrow here, isn't there? If we see a done signal, and this is done and not button. See, it's hard to write the bar in there. Button bar, let's make it a different color. Don't like that color. Make it blue. Okay. So if what this says is if we're in this state right here and we don't see a done signal, then we just stay in that state. But if we see a done signal and the button is not pushed, then we can go back and wait for somebody to push the button again. If the music's done and nobody's pushing the button, then we can go back here and wait for a new button push. This other arrow right here, if we see a done signal but the button's still pushed, then we have to go and wait for the person to release the button before we can watch for it to be pushed again. Okay, and if that in code is if done equals 1 and button equals 0, in other words it's been released, then we get to go back to the no button and we are done. But if done equals 1, and since we've already taken the case where button in equals 0, if we're over here and we have done equals 1, that means that the button in equals 1. Then we go over here and we sit here until somebody releases the button. Okay, then the last state is this one over here where the button's still being pushed, but we have a done signal. So the button's being pushed and we already have a done signal, and we're sitting right there. If the button is released, in other words, a button in equals 0, then we want to go to the new state. Otherwise, we just sit here. And if we're just sitting there, we don't need to reset the value of doorbell state, because it's already set to this value up here. And then just for safety purposes, if there's some weird value in here, which we won't have, then we go back to this state right here. All right. I know talking about code is kind of boring. Let's just do